Hello, geometry students. This video is going to do give you a little review of ratios and proportions because we're going to need them during our study of similar polygons, which will be the next thing we tackle. So what is a ratio? A ratio is just a comparison of two quantities through division. And I'm going to show you the three things you have to always remember about ratios by this example. So in this example, there is a small bonsai bald cypress tree that's only 15 inches tall. It's really short. And there's a really tall height of a Florida bald cypress tree called the Senator that's 118 feet tall. And we're asked to find the ratio of those heights, the ratio of the heights of the bonsai to the Senator. The first thing you have to remember is that order really matters with ratios. If you're asked to do bonsai to Senator, then the short bonsai tree has to come first and this taller Senator has to come second. Order matters. The next thing is you've got to get the same units. And since I would recommend getting them in the smaller units so you can avoid decimals and then you can reduce your final fraction because you need to be comparing two numbers. And so 118 feet times 12 inches in every foot will give you a total of 1,416 inches. That is the same height as 118 feet, but just in inches. So now we have the same units, and so we can set up our fraction. The order matters, bonsai to Senator, 15 inches to 1,416, and we can reduce that fraction. And there are three possible ways that you can express a ratio. You can write it as a fraction, you can write it using a colon, or you can write out the words 5 to 472. Those are three ways that it can be expressed. So three things to remember in red and three ways to express a ratio over here in black. So practice this example on your own paper and then press play. So we are asked to find the ratio of the first measurement to the second measurement, and that order matters. So we've got to make sure that when we set up our ratio, the tennis racket is on top. The next thing we have to realize is that we have to get the same units. So we want to get them all in inches in this case. And so we have to convert 2 feet and 4 inches into just inches. 2 feet, 2 times 12 is 24 inches. Plus these 4 inches gives us a total of 28 inches for that tennis racket. And the table tennis paddle's already in inches. So now we can set up our fraction in the order here, 28 to 10, and our last step is to reduce the fraction, and we could express the ratio in three different ways. Now, an extended ratio is when you compare three or more quantities. So if you say the sides of a triangle have a 3 to 5 to 6 ratio, this would be the meaning. And this is a word problem where, hey, we're told these sides have a 3 to 5 to 6 ratio, and guess what? I know the perimeter is 98. In that case, I could set up an equation. I could combine like terms. I could solve for x and plug it in to find the lengths of those sides. So you practice on this problem and then press play for the solution. If this triangle has an extended ratio for its three sides of 4 to 7 to 9, then 4x, 7x, and 9x could be the algebraic expressions for those sides. And if their perimeter is 60, they'd all add up to 60. So I'd have my equation, I could solve for x and plug it in to find out my side lengths. Okay, the next thing I want to review are proportions. A proportion is an equation that states two ratios are equal to each other. Before I go on to talk about the properties of proportions, I have to remind you of some vocabulary. When you have a proportion, this ratio equals this ratio, extremes and means are two important words. The extremes are on the far outsides and the means are in the middle. If you're writing it as fractions, the extremes are on the tippity top of the first and the bottom of the second, the highest point and the lowest point. And the ones in the middle are the means. Means. Okay, those words are important because our first property is if you have a proportion, the product of the means equals the product of the extremes. So in this case, 2 times 6 would equal 3 times 4. So pause, practice on your own paper, and then press play. The extremes are 6 and 4, the means are 5 and x. So product of the means, 5x. Product of the extremes, 6 times 4, 24. Once you have that, you could always use it to solve for x. Pause, practice on your own paper, and then press play. The extremes are quantity y plus 4 and 3, and the means are 9 and y. So product of the means equals product of the extremes, and then you could use that to solve for y. The next property of proportions is a reciprocal property of proportions, which states that if you're given this proportion, you could flip, everybody could flip upside down, and it would still be a true equation. So let's pause and practice applying both these properties to this given proportion. If we want to apply the reciprocal property, we flip everybody upside down. 7 over a equals b over 13. If we want to apply this property, the product of the means equals the product of the extremes. Pause, practice on your own paper, and then press play to apply both these properties. To apply the reciprocal property, flip everybody upside down. To apply the product of the means equals the product of the extremes, you get 5x equals 36, and then you could use it to solve for x. The next property is a mean switch. So that states that if you're given this proportion, this ratio equals this ratio, the extremes are in black, A and D, and the means are in the middle, B and C. And you can switch them. They can switch spots, and you still have an equivalent equation. So pause and practice applying this, and then press play for the solution. You could rewrite the proportion just as it is and circle the means, and then switch them. You can also always reduce a fraction whenever possible. So pause and practice applying all three properties, and then press play. Reciprocal, flip everybody upside down. Mean switch, figure out who your means are, and then switch them. And reduce when you can. And product of the means equals product of the extremes. And you can solve for b if you'd like. The final property is a little harder to see, so I'll do a little review of adding fractions. Basically, all we're doing is adding 1 to both sides, but it can look a little funky with variables involved. So I want to remind you how we add fractions. If you wanted to add 1 to each side, you would have to get a common denominator before you could add. Here I would be wanting a common denominator of b, whereas over here I'd need a common denominator of d. In order to do that, I would have to multiply top and bottom by b here, but over here I'd have to multiply top and bottom by d. Then I'd have my common denominators on both sides. When you're adding fractions, as soon as you have a common denominator, you can hold it steady and add across the top. So this turns out to be the final property I'm going to talk about today, that if you're given this proportion is true, it's equivalent to this, because basically all I did was add 1. So you practice on your own paper, pause, and then press play for the solution. If I was going to add 1, I'd have to get a common denominator, and then I could hold that denominator steady and add across the top. Pause and answer this question, and then press play. You can see all I did was add 1 over here, so I'd have to add 6 over 6 over here, and I'd get x plus 6 over 6. You can also subtract 1. You can see that in order to get from here to here, I subtracted 7 over 7. So pause and answer this one. I would have to subtract b over b. So pause, practice applying all of the properties to this given proportion, and then press play for the solution. Reciprocal property, flip everybody upside down. Mean switch, I figure out who my means are, and then I switch them. And I can reduce any fraction I come across. Add 1. I am just going to add 1. I can start by reducing the fraction and then just add 8 over 8, add n over n, hold the denominator steady, and add across the top. So I will leave you with this combination of flowers, a kitten and a puppy, and wish you a great day.